Greetings everyone. I am Bhargavi Trivedi and I am currently working as an assistant professor in Department of Biotechnology and Biochemistry at LG Institute of Applied Sciences. So in today's tutorial you are going to learn regarding the different cell recovery methods that are mainly used at the industrial scale.
Cell removal methods is the part of the paper BT 302 Biochemical Engineering semester 5. So, cell removal method is the part of the downstream processing, and it is also referred to as the solid liquid separation methods. Okay. So, as per the basic understanding of the downstream processing, we know that when the fermentation is over, the product is formed. Now, apart from the product, in the fermentation broth, we will also have the dead biomass of the cell debris, other suspended solids, and undissolved salts, and other some fermentation medium components which are unrequired. So they are acting like impurities in the fermented broth. Now, in order to get the product, first we need to remove the impurities. That's why removal of the solid is the first step in the downstream processing. Now, it is not always necessary that we are going to use the solid portion only. Depending on the nature of the product, we can also require the liquid portion. So, if the desired product is extracellular in nature, then the solids are collected and they are disposed. The supernatant is used. For example, in the enzymes are lighter in weight. They are directly excreted outside of the cell. So, they will be present in the supernatant, or you can say the liquid. So, the solids will be removed. If the desired product is the whole cell, for example, yeast is mainly used in the baker's industry. Okay, so if you require such product, then you have to remove the liquid part and you have to retain the solid part. If the desired product is intracellular in nature, then we have to first go for the solid liquid separation before going for the cell disruption methods. Okay, so there are different cell removal methods that are available. First is the filtration. The second method is the centrifugation. The third method is the sedimentation. The fourth method is the foam formation, or you can say the flotation method. And the fifth method is the flocculation methods. Now, these five methods that are generally used at the industrial scale. Each of these processes has unique principle by which it works to separate out the solid content from the liquid. So let's talk about the first method, that is the sedimentation method. In the sedimentation process, the particles that are present in the suspended forms, they are going to settle down. Okay, they settle down because of the natural effect of the gravity and the or you can also use the artificially induced gravitational fields. Now, once the particles, they all will get settled down after a certain time t, whatever the material that is present over here, whatever the suspended particles it is got settled over here, they are known as the sediment. And you can only use this method if the particles are denser than the liquid. Remember, if the particles are not denser than the liquid, then they will never ever come under the influence of the gravitational force and they are never ever going to get settled down. So before proceeding for the sedimentation method, it is mandatory to know the particle size, because then and then only you are going to use this method. Now, when the particles, they are settling down, they are acted by three forces. One is the buoyancy force, the another one is the drag force, and the another one is the gravity force. So, in order to know that for what time, or for to know the sedimentation rate, it is compulsory to know, it is mandatory to know the terminal settling velocity, because eventually that terminal velocity of the particle will decide the time of the operation of the settling time. So basically, it is governed by the Stokes law. So when you try to balance all these three forces, you will come across one equation of the terminal velocity, which is V is equals to T square upon 18 mu rho s minus rho l. This G represents the acceleration due to gravity, where D is the diameter of the particle. Rho 1 is the liquid density, rho s is the solid density, mu is the viscosity of the fluid. And in the same way, if the centrifugal force is going to use, then this Gc is replaced by the omega square r, where omega is the angular rotation of the centrifuge, and r is the distance of the solid particles from the center of the axis of the centrifuge. Now, more the terminal velocity, the sedimentation rate is going to be the faster. As you can see in the diagram, this is the settling tank where the slurry is fed over here. Okay, so the particles density is higher than the liquid density. That's why they got settled after a certain amount of time, certain period of time. Now these solids we can collect the solids separately. And if you want the liquid portion, then you can also collect the liquid portion in a separate tank where it is further heated. Now, the next method for the cell recovery or cell removal method is the flocculation method. Flocculation method is used when the particles cannot settle down with the help of the sedimentation methods because the size of the particle is less than zero point 0.1 micron. Now they will always remain in the suspended form because of the electrostatic forces. On the surface of the cells, they have charge. So as soon as they will try to come near to each other, they will feel the electrostatic repulsions and they will always remain in the suspended form. So in order to settle down such small size particles, first we need to neutralize whatever the charge that is present on the outside of the surface. So for that we need some flocculating agents, or you can also say that we need some coagulating agents. So the flocculating agents or coagulating agents they are nothing, but they will help in finer particles to get clumped by neutralizing the charge that is present on the surface. Now there are different types of flocculating agents that are available. It can be aluminum, ferrous, calcium, magnesium, acid, base, electrolytes, etc. Now, if you see that they all are multivalent, for example, Al3 plus, Fe3 plus, calcium 3 plus, magnesium 2 plus. So, this will help in neutralizing the charge that is present on the surface. Now, once the charge is neutralized, they can come and they will no longer experience the electrostatic forces of repulsion, so they will form the aggregates, or you can say small flocks. Now this flocks may float to the top of the surface, or it can settle down to the bottom of the surface. So the overall main mechanism that is involved in the flocculation is the charge neutralization. So as you can see in the figure, you can see that if the flocculant is added at time t is equals to 1, then for some time it is allowed to form the flocks. Then if the flocks are heavier, then they will get settled down at the bottom of the tank, and you can collect them, or if you want the liquid part, then you can also collect the liquid part separately. But if when the flocculants, or you can also say coagulating agents are added, and if the flocks that are formed that are lighter in weight as compared to the density of the liquid, they are going to float on the surface. They can also be collected, and if you want the liquid, then liquid can also be collected. The next method here going to use for the cell removal is the filtration method. In the filtration methods, we are going to use membranes that are having the pores of the fixed, or you can fixed diameter. So according to the basic principle of the filtration, through the semi-permeable or membrane that are having pore size, the solids they are going to retain, and the liquid is going to flow through the membrane. Now the filtration has two different types of the filter media. One is the surface filter and the another one is the depth filter. So if the filtration is taking place on the surface itself, then such type of filter media they are referred to as the surface filter media. And if the filter is taking at some depth of the membrane, then it is going to referred as the depth filter media. So for example of the surface filter is the belt filter, rotary vacuum filter. The examples of the depth filter is the sand filter. So as you can see in the diagram of the surface filter, when the feed is coming through, the all the major filtration is taking place on the surface. Only the filtrate is allowed to pass through it. While if you look at the depth filter, then the feed can completely come over here and the filtration is taking place at some depth layer. And then the fluid is passed and then the fluid is passed. So that's why it is referred to as the depth filter. Now, the efficiency of the filtration depends on the many factors such as the size of the organisms, presence of the other organisms, viscosity of the medium, and the temperature. Now, let's see the what are the main types of filter setups that are mainly used at the industrial scale. First one is the horizontal design. So, in the horizontal design, filter membrane is kept over here in the horizontal way. That's why it is referred to as the horizontal design. And the feed will be added over here from the, it will pass through the filter medium, or you can say your filter membrane, and whatever the permeate will be collected, and here the solids will be retained. Slowly the solid layer will get increase in size, which is referred to as cake, or sometimes we also say that small solid particles are referred over here. There is a support plate over here which supports the filter medium so that when it gets wet it doesn't breaks down. Now the second design that is used, that is the plate and frame design. So here the frame, your plate is kept over here in the vertical way. So the slurry will be passed from here and there will be filter medium which will be supported by the plate. So it will hit the plate. Now whatever the solids, they will be retained over here and the liquid will pass through it. And if you want to collect the cake, then you can also collect the solid particles, and you have to go for further drying and other process. The third type of design that is commonly used is the candle filter. Now why it is named as candle? Because here it is placed like a candle and it is porous in nature. So as soon as the feed will enter, it will go through all the pores that are present, and eventually once after going through the pores, the liquid will get collected out and the solid particles will get retained inside the candle. The another type of design that is used is the rotary drum filter setup. It is mainly used for the continuous process. In the batch process, you can use the filter designs that we have discussed previously. So this drum is continuously rotating. So the feed is over here. So as the drum will rotate, it will come in contact with the feed. Now it will come upwards because it is rotating. So when it will come upward, there will be cake formation over here because it will also bring out some feed from it. So there will be cake formation. Slowly when it will go here, there will be washing step that is performed over here. Then when it will move here, it will be dried, and then it will move over here. The solid particles that are dried will be removed by using the cutting knife, and again the drum will rotate inside. Then the drum will get deep inside the feed slurry and the process will keep on continuing. That's why this is known as rotary drum filter setup method. Now let's talk about another method, that is the belt filter setup method. This is also used for the continuous process only. So if the name is belt because there are rotary belts that are used over here. There is one roller over here and this belt is continuously rotating. So from here the slurry will be feeded. When the slurry is feeded, it is initially wet. Okay, it is in the solids that are present in the slurry are wet. Once it will pass through the filter, it will get squeezed. Okay, or you can say pressed. So when it gets pressed, the water that is present inside, the water that is present inside the cell will get dewaterized, or you can say the whatever the water content is removed. It will pass through all this. So at every interval the cells are getting pressed and the water is getting removed. So eventually at the end we will have the cells in completely dried up. That's why this method is known as the belt filter setup method. Okay. The next method that is used for the cell removal, or you can say cell recovery method, is the centrifugation method. So, as we know that the centrifugation method is based on the principle of the density differences between the particles to be separated and the medium medium. So more the denser the particles, they will settle down first, and less the denser the particles, they will settle down at the last. Because the more dense the components, they will migrate away from the center of the axis. So this is the center of the axis, so they will migrate away. That's why they settle down fast. They will hit the wall and then they will go and settle down at the bottom. So there are many different types of centrifuges that are used in the used at the industrial scale. We are going to discuss two of the centrifugations that are mainly used at the industrial scale level. So first of them is the tubular bowl centrifuge, and the another one is the disc centrifuge. So what happens in the tubular bowl centrifuge, that our slurry is fed from here. Now here there is a bowl and it is always rotating. That's why this type of centrifuge is known as the tubular bowl centrifuge. So as soon as the slurry that is having the solid and the liquid particles will come in, it is going to rotate. So the entire bowl over there is going to rotate, and the solid particles will get hit on the surface of these bowls, and it will get deposited in the form of the slurry, which we generally refer to as cake. So now these solid particles will get retained over here, and whatever the liquid fluid is there will go out and it will be collected from this exit pipe. Now, if you want to collect the solid particles, then you have to remove it separately and then treat it separately. The next type of centrifuge is the disc type centrifuge. So here the name is disc because the discs are arranged here. Now, as soon as the feed will enter from here, the solid particles, they are going to hit at this disc. Now, as soon as they will get hit by the disc, they will get thrown out onto the surface of this centrifuge, and they will eventually get deposited over here. And whatever the fluid will be there, whatever the liquid part will be there, will be easily going up, and it will be collected and it will be collected into the separate tank. So the solids will get deposited over here. Now the next technique is the foam separation technique for the cell recovery method. Foam separation method is divided into the two parts. One is the foam fractionation and another one is the flotation. So let's first talk about the flotation method. So here the flotation method is used for the removal of the coarsely dispersed material. Now the foam separation method is used when the solid particles are really small and cannot be separated out by using some coagulating agents or by using some another agent. So you are going to use the flotation method. So what happens in the flotation method, that the air is introduced in the form of a gas. Now from the sparger, when the gas will come up, it will form small bubbles. So the bubbles will come at the top of the tank. The bubbles will have the absorptive properties, and the solid particles, they will get absorbed with the bubble, and along with the bubble they will also come at the top of the tank. So the froth is formed at the top layer. it is formed up to a certain extent, and once it is formed, it is collected in the separate tank where it is further treated for the further, so it can go for the further purification step. And in the flotation method, only air is used. There is no use of surfactants in it. Now let's go to the second method. The next method is the foam fractionation method. So here in the foam fractionation method, we are going to use surfactant along with the gas. So surfactants, they are nothing but they are the surface active agents. Now the surfactants have the surface tension as well as polarity in some cases. So along with the gas, there will be surfactants that will be involved. Now, because of the surface tension and the polarity, they are going to attract few small particles along with them. So they will form a foam at the top of the tank. The one should take care that the foam should not reach till the top. Okay. Otherwise, if the tank is closed, then there are chances of getting contamination. So once the foam is formed, it is taken into the another foam beaker where it is further treated for the next purification step. Now this technology is also known as the adsorptive bubble separation because the adsorption is taking place at the surface of the foam bubble. Now the one should always keep in mind that a surfactant should never ever react with the product, so it should be chemically inert. Otherwise, the product will get converted into some another form, or in case of the proteins, we can also get denatured. So this is all about the cell recovery or cell removal methods. And here are some recommended readings. So I have also mentioned some reference book and web reference. You can always go through this book and can enhance your understanding regarding this topic. Okay, and if you have more questions, then you can always email me your questions at my id bhargavitrivedi.lgis@lginstitute.edu.in. Okay, thank you.